All right, number 1. When it says a factor of 6, that means it will evenly divide 6. So what are the numbers on a die? 1, 2, 3, 4, 5, 6. If I divide 6 by 1, do I get a whole number? Will it go in evenly? Yep. What about by 2? Yep. 3? 4? No. 5? 6? Yes. Nope. Factors of 6 are 1, 2, 3, and 6. What do you mean how? 6 divided by 1 is? It's a whole number. Again, a factor means it will evenly divide that number. Yeah. So to determine whether or not something is a factor, if you divide it by that number and you get a whole number answer, then it's a factor. So the probability that it is a factor of 6 would be what? Close. 4 over 6. We have 4 numbers. 1, 2, 3, 4 of the numbers on the die will evenly divide 6, and we have 6 total sides, so 4 over 6. What is 4 over 6 as a decimal? As a decimal. 0. We'll call it 667, which would be 66.7%. All right, number 2. 2 dice are rolled. The probability of getting a 6 on one die and, what symbol means and? Upside down U. 6 on one die and an even number on the other die is 0.083. So the probability of 6 and even is equal to 0.083. We want to know, are these independent events? So I'm going to ask myself, does the probability of rolling a 6 on a die times the probability of getting an even number on a roll equal the probability of getting a 6 and an even number? We know this number. They gave that to us right there. What's the probability that if I roll a die one time, it lands on 6? 1/6. What's the probability now if I roll this same die again, I get an even number? How many even numbers are there?
3.
There's 3. 2, 4, and 6 are on here. So 3 out of 6. We're going to multiply those together. How do we multiply fractions? Straight across. Oh, I wrote 1 over 2. It's 1 over what? 1 over 6. Sorry, guys. So when I multiply those two together, I get 3 over 36. But they gave me a decimal. So I'm going to need to divide this on my calculator so that I can actually compare it to what they gave me. 0.083. This over here, they gave me a decimal for. They said it was 0.083. Are those two things equal?
Yeah.
So what does that mean? It's dependent?
Oh, independent.
It's independent. So yes, they are independent. All right, last problem on the bell work. Marco went to the state fair to find out what the favorite food is of all attendees. Stop right there. Who does he want to get information from?
All the fair attendees.
Yes, all the state fair attendees, yes. So who is the population?
The state fair attendees.
All state fair attendees. The who that I'm interested in is my population. Who do I want information about? Well, hold on. Again, the who is the population. We already answered that. That's all of the state fair attendees. What does he want to know about all of the attendees? Their favorite food. Marco went to the state fair to find out what the favorite food is. They didn't ask us for this. But this piece right here, what is their favorite food? Of all attendees, this is the parameter. What is the sample? The sample is who he actually talked to. Who he wants to know about is the population. The sample is who he actually talked to. Yes, 50 attendees at the state fair in line for Ben's pretzels. Be careful with this last question. We want to know, is this bias? Remember, it is bias if my sample, who I actually got my information from, does not represent all the different possible viewpoints of my population. Who did we say the population was again?
All the state fair attendees.
All the state fair attendees. Who was the sample?
50 people in line.
50 people in line for Ben's pretzels. Do you think those 50 people in line for Ben's pretzels have all the different opinions about food that we would see if we talked to everybody that was at the state fair?
No.
So is it bias?
Yes.
Yes. Because they're already in line for one particular type of food, you're probably going to get a lot of people that say this is their favorite food at the state fair. You're leaving out all the people that don't like pretzels and have some different favorite food there. So because they are already in line for food, they do not represent the whole population. So what would be a better way for Marco to get his sample? Going up to people that are already in a food line is probably not a good way. What would be a better way?
Just to like find them when they're not.
But I'm wanting to know how he finds the people that he's going to talk to. How should he go about picking out the people that he's going to talk to so that he's not leaving out any large group? He can't talk to all the people at the state fair because people are coming and going all day long, right? So what would be a better way for him to collect this sample?
The food place that sells more.
A food place that sells more? Is there any food place at the state fair, though, that would have all the options available at the state fair? Probably not. So how could he go about doing this? How could he pick out a sample to make sure that all the different opinions are represented in his sample? What do you guys think? Not doing it at all isn't an option. How could he pick out his sample? If you wanted opinions from people at the state fair, what would you do? Ask who? Could set up a survey booth. You'd probably get people with lots of different types of opinions that would come up to you. You could go up to random people at the fair. Go up to some people that are near rides. Go up to some people that are near shows. Go up to some people, like just go up to random people at the fair instead of getting them all from one particular food line. Any other ideas? Have a couple of people go to collect the data and go to every single food line and get a couple people in each of those lines. Those are all much better ways of sampling than just going to one food line. Absolutely. All right. In your notes packet, we're going to be on page 16. Yesterday, we started talking about statistics. And when we started talking about statistics, we had to define populations and samples, parameters, statistics. We talked about bias. Today, we're going to start actually finding some statistics. So after we've collected all this data from these people, what are we going to do with it? You guys have already calculated some statistics before. The mean is one type of statistic. Have you guys ever found the mean?
It's like you put them in order and you knock them off. No, that's the median.
That's the median. I like that. You put them in order and knock them off for the median, and knock them off until you get to where?
To the middle.
To the middle. So the median is the middle. Put the data values, the numbers, in order from smallest to largest, and you find the middle. If, as you knock them off, you end up with two numbers in the middle.
You add them together and you multiply by 2.
Not multiply, divide, yes. We're going to average them, which means add them together and divide them by 2. So if the median is the middle, I put them in order, I knock them off until I get to that number right in the middle. What's the mean? How do we find the mean?
Add them together and then you divide them by.
Yes, that's absolutely right. The mean is the average. We're going to add up all the data values, add up all the numbers, and then we're going to divide by how many data values, how many numbers there are. Have you guys found the mean and the median in the past?
Yeah.
Cool. You guys have found statistics. What do you think minimum means?
The number, no, the smallest one.
Smallest number. Minimum is the smallest. So with them still in order from finding the median, the minimum is the smallest data value. So I need them in order from smallest to biggest. And then the minimum is the smallest. What about maximum? That would be the biggest, the greatest, or the largest. So again, I need my data values in order from smallest to largest, and then the maximum is the biggest one. After you guys get this information copied into those 4 boxes in your notes, I want you to practice finding these with the data set, the list of numbers that is right below these boxes. You will need a calculator to do the mean. If you don't have a calculator, you can borrow one from me, or you can use the calculator on your cell phone. After you've had a chance to copy all of this down into your notes, I want you to practice finding these 4 values from the list of numbers that is right below these boxes. For mean? For median, you put them all in order. For median, you put them all in order from smallest to biggest.
No, I'm talking about if they're like 2
If there's 2 middle numbers, you take those 2 numbers, just the 2 middle ones, and you add those together and divide by 2. If you're done with this part, then you need to do this part. Put your phone away, please. You can find mean and median.
Exactly.
Okay, good. Then do it. Do it right here. Show me that you can find it. If you've done this, you need to actually find them right here, that data set. Let me look. something got put in wrong.
Is that right?
Yes. That's not correct. That is correct.
5 plus 7. 5 plus 7 plus 9 plus 13 plus 9 plus 7 plus 8 plus 11 plus 14. 75 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9.
There.
Oh.
That's correct.
Do I put the 3 decimal places?
Yes, take it up to 3.
Add these divided by 7.
They have to be in order. For the median, they have to be in order.
This is order, right? Yeah.
I got it. And then cross out.
Uh-huh. And you said 5 middle.
Yep.
And if there's 2 middle, then I add it.
So is there going to be 2 middle values here when you cross out?
Yeah. Or I missed a number.
How many numbers do you have there?
9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
Then there should not be 2 middle numbers.
Oh, okay.
What are we getting for the mean? What'd you say? 8.33333333333. Yes. So the mean, we take 5 plus 7 plus 9 plus 13 plus 1 plus 7 plus 8 plus 11 plus 14. What did you guys get when you added all those up?
8 point, oh, 75.
75
Divided by 9.
divided by 9. Why by 9? Yes, there were 9 values. There were 9 numbers there. And you should have gotten 8.3 repeating, so 8.333.
It repeats about 9 times.
Yes.
Why don't we do mode?
We could do mode. That's just not one of the commonly used statistics. Mean and median get used a lot. Yes, mode is very, very easy. For median, I need the numbers in order. So help me put them in order. What would come first? 1, and then? And then? After that? Another 7, and then? 8, 9, 11, 13, and 14. So in order here, I'm going to start crossing them off from the outside and working my way in. So I cross off the 1 and the 14. I cross off the 5 and the 13. I cross off the 7 and the 11. I cross off the 7 and the 9. And I have 1 number left in the middle. That is my median. So the median here is 8. What is the minimum? What is the smallest number? 1. Here's my minimum. What's my maximum? 14. Nicely done. Have you guys done that before? Smallest, biggest, mean, and median. There are 3 new statistics that we're going to learn about today. They're very easy to find, just like these. One of those new statistics is called the lower quartile. The other one is called the upper quartile. How many quarters are there in a dollar? 4 quarters in a dollar. When we talk about quartiles, we're going to take our data set and we're going to split it into 4 equally sized pieces. The median cuts it in half. The lower quartile also called Q1, because lower quartile is a lot to write. So we also call this Q1. We are going to take all of the data that is smaller than the median. So every number in that list that is smaller than the median, we're going to line them up, and we're going to find the middle of that. The upper quartile, we also abbreviate this one as Q3, because again, upper quartile is a lot to write down. This time, I need all the numbers in the list that are bigger than the median. So I line up all the numbers in that list that are bigger than my median, and I find the middle of that. So Q1 and Q3. I often get asked why there's no Q2. There is. We just normally refer to it as the median. So those are two new statistics. Can you pass? So everything smaller than the median, we line it up and find the middle of that. Everything bigger than the median, we line it up and find the middle of that. That's my lower and my upper quartile. The interquartile range, we abbreviate that as IQR, because again, that's a lot to write. The interquartile range, we're going to take this number right here from the upper quartile, because that's going to be the bigger number. And we're going to minus the lower quartile. We're going to minus Q1, the smaller number that we found. Upper quartile minus lower quartile. This is going to give me the range of the middle half of the data. When you are done copying this information into those bottom three boxes, I want you to flip the page. And I want you to find just the top three things from that data set. I want you to find the minimum, the maximum, and the median. And then we'll find these new statistics together. Once you're done getting this copied into your notes, flip the page. And with that data set that's up at the top of the page, I want you to find the minimum, the maximum, and the median. page 16 down at the bottom. Put this one away and work on this.
You said fine, what did you?
I want you to find the top three boxes, the minimum, the maximum, and the median. Goes in those top three boxes. We'll do the bottom three together.
Okay, so question.
I want you to answer these three questions.
So like, on this one, like, when you say the middle, like, you said the middle value of the got a smaller than it, so everything.
What do you
is
have
smaller?
to do to find the median?
You gotta like cross it out and stuff.
What do you have to do before you cross them out?
Oh, dude, watch the smaller.
All right. What do I have to do to these data values before I can answer any of the top three boxes? Put them in order. So what number would come first if I put them in order, smallest to largest? 2, 3, 6, 7, 8, 8, 9. So where is my minimum? What is my minimum value? 2. So the minimum is 2. What is the maximum? 9. To find the median, only after they're in order, I can cross them out and get to the middle. So I'm going to cross out the 2 and the 9, the 3 and the 8, the 6 and the 8. So what's in the middle? 7. Here's my median. All right, now the bottom three boxes, the new pieces. For the lower quartile, I want all the numbers that are smaller than the median. All numbers smaller than the median. What's the median? 7. So give me every number in that list that's smaller than 7. 2, 3, 6. And for my lower quartile for Q1, I want to find the middle of that list. What number is in the middle of that list? 3. There's my lower quartile. For the upper quartile, I'm going to make another list, but this time I want all the numbers that are bigger than my median. And what's the median again? 7. Give me every number in that original list that is bigger than 7. 8, 8, and 9. For my upper quartile for Q3, I want the middle of that list. 8. Right in the middle here. How do we find the IQR? Upper minus the lower, or Q3 minus Q1. What was Q3 again? 8 minus, what was the number we got for Q1? 3. So what is 8 minus 3? 5. You have to start off by putting them in order. Minimum, maximum, then find your middle, find your median. Once you know where the median is, every number on that list that is smaller than the median, you write down and find the middle of that. That's Q1. Every number on that list that is larger than the median, you write down and you find the middle of that. The IQR is where you take and subtract those two. Do you guys have any questions on this so far? All right. Let's look at the next one. Go ahead and put those numbers in order for me. For that next data set, put the numbers in order. What do we start with if we're going smallest to largest? 5, and then? 5.8, and then? 6.6, 7.1, 7.6, 7.9, 8, and then 8.8. All right, I've got them in order. Minimum, 5. Right, here's my minimum. Maximum, 8.8. Right here. And then we go to find our median. So I cross out the top and bottom. And then I move to the next two. And then I cross out 6.6 and 7.9. What happens if I cross out 7.1 and 7.6? I got nothing left. So I have two numbers in the middle there, right? Add them together and divide them, because the median is halfway in between these two numbers. So I have to take both of these, add them together, 7.1 plus 7.6, and divide by 2. So I have 14.7 divided by 2, which would give me what? 7.35. That is my median. So to find my lower quartile, I want all the numbers smaller than the median, which is 7.35. Looking at this original list of numbers, which ones are smaller than 7.35? Yes, 5, 5.8, 6.6, and 7.1. And I want the middle of that list. What happens when I start crossing them off, though? Yeah, so I have two numbers in the middle here. And the median, the middle of that, is halfway in between those. So I treat it just like when there were two numbers in the middle for my median. I have to add those together, 5.8 plus 6.6, and I divide it by 2. Whenever there's two numbers in the middle, we add them together and divide by 2. So I think that's 12.4. Somebody double check me on a calculator. I did it in my head. 12.4 cut in half. 12.4 divided by 2 would be what? 6.2. So that is my lower quartile, my Q1. For the upper quartile, I need all the numbers that are bigger than the median. What's the median again? 7.35. So read me every number off that original list that is bigger than 7.35. 7.6, 7.9, 8, and 8.8. And now I need the middle of that. What happens when I go to find the middle of that? There's 2 in the middle again. So Q3 is halfway in between those. So I have to add them and divide by 2. So 7.9 plus 8 divided by 2. $7.9 plus 8 is what? 15.9. So I have 15.9 divided by 2, 7.95. How do I find the IQR again? Yes, subtract the upper, Q3, and the lower, Q1. Q3 will always be the bigger number. So 7.95 minus 6.2. What is 7.95 minus 6.2? 1.75. Very nicely done. Turn the page for me. There's just a little bit more that we're going to do today. And then we will wrap up this module on Monday. So the minimum, the maximum, the median, and 2 of those new statistics, Q1 and Q3, the lower quartile and the upper quartile. That's 5 different numbers, minimum, maximum, median, lower, and upper. When we have those 5 numbers, we call it the 5-number summary, and we use those 5 numbers to make a graph. The graph is called a box plot, sometimes called a box and whisker plot. Because right in the middle of that graph, we've got what kind of a shape? I have a rectangle, have a box. And off on either end are the whiskers. This first line over here, the one on the left, that is the minimum. So I can follow this whisker down to the x-axis here, and that tells me the value for the minimum. So if the farthest to the left is the minimum, what do you think the farthest to the right is showing me? If farthest to the left is the minimum, what do you think the farthest to the right is showing me? The maximum. So on this graph, if I take that down to the axis here, that looks like it's at about 220. I have to kind of estimate it because it's not falling right on a number. So minimum and maximum are the farthest left and farthest right. The left edge of the box, right here, that is the lower quartile. That is Q1. So again, I can follow that down to the axis down here. More than halfway. I'm going to guess that that's right about 65. All right, so minimum lower quartile is the edge of the box. What do you think the other edge of the box is representing? The upper quartile, or Q3. So again, I can kind of follow this down. I can't tell exactly where that is, but it looks like it's at about 160. And then it's really hard to see on this particular graph because it printed really lightly on your page. But do you guys see that line that's inside the box? If I've got the minimum, Q1, Q3, and the maximum already labeled, what do you think that one in the middle is? The median. So if I follow that down here, looks like it's right about 120. The IQR that we've been calculating, where we do Q3 minus Q1, that's this right here. This is my IQR. This represents the length of the box. So how wide is that box? That's what the IQR tells me. And that's where we're going to stop for today. On Monday, we will look at a data set. We will find our 5-number summary. And then we will create a box and whisker plot from that data. Things that you guys need to remember. Homework number 4, that was the homework over independence. That is due today. Homework number 5, which is your last regular homework of the entire semester, is due on Tuesday. We are on pace to finish up this entire module on Monday. If for some reason we don't get all the way done with it, then I'll bump that homework out a day. All right? Don't forget to turn your bell work in before you leave.
I mean,